Last video, we left off here with this negative light. This is the sun behind the viewer. And we just randomly picked out a ground line vanishing point. It needs to be on the horizon line. And I just randomly picked out a light angle vanishing point. It needs to be aligned with the ground line vanishing point. But we can make this a little more specific, putting the light source in a really particular place in space. So here's this scene. It's a scene here where the viewer is looking this direction, and this is 90 degrees from where the viewer is looking, this cross section. The sun can be anywhere along this hemisphere, and if the sun's behind the viewer, then it is considered negative light and the shadows are going towards the horizon line. So this is 90 degrees to the left of where the viewer is looking, 90 degrees to the right of where the viewer is looking. There's 360 degrees around this viewer. So if we want to put this ground line vanishing point in a particular place, we're looking at angles that are beyond 90 degrees. Here's 90. If I go 10 more, it's 100, 110, 120, and you could keep, it's just like a protractor going along in through here. And probably the easiest way to think of it is this is 0 and 90 to the left, 90 to the right. So this is the station point. So if we wanted to put the sun in a particular degree from where the viewer is located, we are looking at something like this. Here's our viewer, here's the station point. If I drew a line straight across here, parallel with the horizon line. So here's 90 degrees to the left, here's 90 degrees to the right. So if we wanted to make, well, let's get out this, we'll put this protractor right here. So here are degrees past 90. Here's 0, here's 90, even though it's kind of different on here. So here's 100, 120, 30, 40, 50. Here's, let's just put a mark right there. And so this is 150 degrees to the right of where the viewer is looking. This angle, we need to project it up to the horizon line because the ground line vanishing point has to be on the horizon line. So if we take this and extend this out, we get a ground line vanishing point that draws shadows that would be 150 degrees from where the viewer is looking. Let's put a little stick here. So the shadows, the sun's behind the viewer, so the shadows are going this way. This is the angle of the shadow if the sun was 150 degrees to the right of where the viewer is looking. Now we could also put the sun in a really particular place up in the sky. Now to do that, we need a place that we can get true angles from. Like this is our spot. The station point is where we get true angles for horizontal lines. This is just, you can just consider this a horizontal line. It's parallel to the ground plane. It's actually going along the ground plane. So we know from that last video that the light angle vanishing point has to be aligned with the ground line vanishing point. It's going to be on a line like this. So that light angle vanishing point is just like an auxiliary vanishing point. And we get true angles for inclines. It's a light angle vanishing point is just a dot that creates an incline. So we get those from measuring points. Like it says ground line vanishing point, but we could just get rid of that and call it a left vanishing point. So to get a true angles for this dot here that's on the horizon line, what we need is this. This is the spot where you get true angles for any inclines that are lined with this. So around this dot, last time we called it a ground line measuring point, even though we don't use it to measure anything with. It's just a spot where you get true angles from. There are 360 degrees of true angles around this ground line measuring point, and there are 360 degrees of true angles around the station point. These are true angles for inclines, and these are true angles for lines that are parallel with the ground. So if I want, let's make the sun, let's make it 30 degrees above the horizon line. So going back to here, let's see. We put the ground line vanishing point 150 degrees. I'm just making this up here, but let's say this is, for argument's sake, this is 150 degrees to the right of where the viewer is looking. And if you extend this out to the edge of the earth, here is 90 degrees from the ground plane directly overhead. This would be a 90-degree angle. Change colors here. So we want to put the sun 30 degrees above the horizon line. Now the sun's behind the viewer, so we know that the light angle vanishing point has to be along this line. So we are going down 30 degrees, which maybe seems weird, but it's really like this is how it works. Here is 30 degrees above the horizon line. This is the angle of the ray of light, the true angle of the ray of light as it in relationship to the ground plane. I kind of made this thing too long, so I can see it's going to be a tangent here. So I'm going to take my antique electric eraser and we'll make it lower so it doesn't create a tangent line. So this is the angle of the ray of light to the ground, the true angle. And we take this and we extend this out. And here we get our light angle vanishing point. I almost said ground line. Okay, so this dot creates this angle in perspective. So if I go from the top of this pole, this is where the shadow would end if the sun was 30 degrees above the horizon line. Where the sun is, if I keep this going, the sun, if I extend this out, this goes, another tangent, this goes to the sun. Let's make a directional arrow like that. This is not the sun. This isn't really telling you the sun is here. This is just showing you the ray of light, the angle of the ray of light as it hits to the ground plane. The sun is back here. It's 150 degrees around to the right of where the viewer is, over the right shoulder of the viewer. And if this kind of came out, it would eventually go to the sun. So the light ray is coming along here and hitting the ground. Here is 30 degrees in perspective. And here's a true 30 degrees. It's coming this way and it's hitting the ground right there. And this is coming along here and it's hitting the ground right there. And from this point, it's going underground, below the horizon line, to this point at infinity, this little vanishing point here. So as this one goes along it hits the ground right there, and it's doing the same thing. It's going from this point, it's going underground as it goes to out here to infinity, to this vanishing point. Might have to think about this one for a little bit. It is a little more complicated than when the sun's in front of the viewer.